This is an activity which can be used for determining the angle sum property of any n-sided polygon. So we have four polygons here: the triangle, the quadrilateral, the pentagon and the hexagon. So we know the angle sum property of triangles. This triangle ABC has got three angles A, B and C. So when you add them together, they are going to sum up to 180 degrees. This is something known to us already from our previous grades. Now the next one is a quadrilateral. This is quadrilateral DEFG. Now we have seen in our previous activity, we can find the interior angles, the sum of the interior angles of this quadrilateral by dividing it into two triangles. Now how did we divide it into two triangles? We just had to draw a line segment joining any two non-consecutive vertices. So once we have joined any two non-consecutive vertices, that is, we draw the diagonal, the quadrilateral is divided into two triangles. So when I want to find the angle sum property of this quadrilateral, that is, I have to add all the interior angles of this quadrilateral. It is equivalent to adding the three angles of triangle DEG and GEF. So these two triangles, if I add their angles, then what I would get is the sum of all the four angles of quadrilateral DEFG. So I know the angle sum property of triangle DEG will give an 180 degrees, and second angle sum property of triangle EFG will give another 180 degrees. So the total angles of this quadrilateral DEFG, when I add all the four angles, they should sum up to 180 plus 180, that should be equal to 360 degrees. Now when I come to the pentagon, again when I draw the line segments connecting the non-consecutive vertices, what I shall be doing is I am drawing the diagonals. So by drawing the diagonals, I have divided or made three triangles out of this complete pentagon. That means the pentagon is divided into three smaller triangles. So if I want to find the angle sum property of this pentagon, that is, when I want to add all the interior angles of this pentagon, it is equivalent to saying when I add the interior angles of three triangles, that is HIL, ILJ and JLK. So this is triangle 1, which will sum up to 180 degrees. The angle sum property of the second triangle again should be equal to 180 degrees. And the third triangle, again the sum of the angles should be equal to 180 degrees. So it will be 180 plus 180 plus 180, which will sum up to 540 degrees. That means the interior angles of a pentagon should sum up to 540 degrees. Now coming to the next polygon, which is a hexagon or a six-sided polygon. So here also I draw the diagonals to divide the given hexagon into triangles. So to do this, I have to draw three of its diagonals and hence dividing the hexagon into four smaller triangles. So the sum of the interior angles of this hexagon, which is M, N, O, P, Q and R, will be equal to the sum of the interior angles of these four triangles, that is M, R, Q, M, Q, N, N, Q, O and O, Q, P. So because there are four triangles here, the sum would be 180 plus 180 plus 180 plus 180, which should total to become 720. So the interior angles of a hexagon should sum up to 720 degrees. So we know we can divide any n-sided polygon into smaller triangles by drawing its diagonals. So we can arrive at a general formula which will allow us to calculate the sum of the interior angles of any n-sided polygon. So this is exactly what the activity will allow us to derive a general formula to get the angle sum property of any n-sided polygon.